Okay, so at this stage, we're ready to start with this application, at least to add some products. Notice I had forgotten to put an N for quantity earlier in one of the attributes for the structure product. Okay, so just a quick reminder, what we did here is we've created 100 products of type product as a local variable. Okay, what I would like to do now is to go ahead and populate a few array members. Okay, so that means maybe a product, maybe two, maybe three. So that means I want to execute this option. Okay, so I need a function that will allow me to do this outside of main. But first of all, let's have a little strategy here. So let me just have a simple if statement. If the option that we receive back from menu, which means the value of choice, right, is equal to 1, which means that is the operation we want to do. I am right now, go ahead, and remember I'm testing the code here, go ahead and add a product. So I'm going to create a function here that allows me to add a product. Okay, now the key behind this is where do you want to add the product? Okay, so we have 100 locations. So maybe I need to keep track of where out of these 100 locations we're going to add a product, especially if you're adding more products later on and appending to existing products. So you need to track where you were the last time you added a product. So fine. So int prod count, and we'll set it to 0. So the initial count will have been 0. And we would like to update that every time we add a product. Aha. So I need, if that's the case, I need prod count, okay, to get an update from a function. Let's say we call it add product. Okay, now I am going to put an argument or a couple arguments here in a minute, but that's the idea. So anytime I add a product, I want this variable, okay, to be updated. So that way the next time I come around, I'm inside of this loop. If I've had 2 products, then the prod count at the end will be 2. If I add another product, then the prod count will be 3, etc., etc. So this here will allow me to track, okay, which index I should use, from which I could append from there, okay? All right, so let's go ahead and create that function add product. So we know it's going to return an integer. Since it will return that integer back to prod count, we're going to call that function add product. Okay, now we have to decide on what kind of arguments it will take. Okay, so 1, for sure we want to pass this array. Now, how do we pass an array to a function? The best way to do it is by reference, which means go ahead and pass the first address of this array. And what would that be? It could be this, and prod 0. Okay, which means over here you need a pointer to point at it. So you need something like this. Now remember, prod is of type product, and it's a structure. So you're going to type something like this, struct product, and since it's a pointer, put an asterisk, call it whatever you want, pptr, okay, and that's how it would match. Now if I compile this, I should be okay, even though I don't have a return statement in the add product. Okay, well, we'll handle that in a minute. So how is this going to update the count? Well, send it the present count. So what do we mean? I want a second argument that has the prod count, the present prod count, and then the future one will be right here. So the initially when you start right from the beginning, this would be 0. This would be the first address, right? So what would be nice is that you need an integer to receive it here, int and let's call it count, okay? And then return count. If you added a product, make sure you increment count. So for now, I'm just going to return count. So I know I'm returning an integer, so I'm going to return the same value if I do nothing, okay? So these should compile just fine. So let me just go ahead and compile. Perfect, because the arguments match. What I'm doing here is I'm passing by value. So I'm passing a copy of prod count to count. What I'm doing here is I'm passing by reference. I'm passing an address to a pointer right here. Aha. Is there another way to pass this address? Yes, you could do this. Watch this. And take out this. So the name of the array, prod, is the actual starting address of that array. So this is another way to do it. I prefer this. It's less cryptic. So let me just go ahead and compile this. There you go. Okay, so the name of the array is the starting address of the array. Okay, now we would like to alter, or actually put a product, alter the content of wherever we are. So, okay, so we could probably here ask the user to enter values to populate these attributes, the name, the price, the quantity. Okay, we'll do it right here. So printf enter the following information or product information. And we're going to do a /n here. And we're going to do something like this. Printf, maybe the name here. Name or product name. Now, here's the interesting part. We need to dereference since it's a pointer. Okay, well, how do we do that? So scanf %s, you're going to enter a string for the name and dereference by using ptr. Okay, so what's in here? Well, that's the address. You could use that. That's dereferencing means what? Go to the actual element that was declared here via this address by using this pointer. Okay, let me just compile this here for a minute. And let me see what I did. Printf, I forgot a semicolon here. It's what happens when you write code from on the fly from scratch. So let me compile here. Perfect. Now we're going to do the same thing for price, but we're not done. That's not good because it's missing. What is it we're dereferencing? We're dereferencing name. Okay, so this is what you're dereferencing. So the name. So let me compile. That is what we're dereferencing. Perfect. Now let's go ahead and dereference price and quantity. So printf product price. Maybe something like this. And then we're going to do scanf. And that would be a %f. Okay. And now do not forget to put an ampersand pptr. You are dereferencing price. You're storing it at that memory location. Okay. Let's do the same thing for quantity. So printf quantity. Now we don't necessarily need to do that with a string. Definitely with floats, integers, that sort of thing. Because name is already an address. Price is not. It's a variable. So you need to say where. Okay, quantity or product quantity. and that would be scanf. And that would be %d and %pptr, and dereference to quantity. Okay. Let's go ahead and compile this for a second. Okay, looks good. Let's test it out. Let me go ahead and print for now. This is a test right here. If we do actually get the product back in main. All right, so printf. I am going to go ahead and print %s, %f, or %.2f if you want, because it's going to be currency. And then a little space %d for the quantity. So I'm going to print these three elements and put a /n here, give me a new line. And I'm going to do prod. So it's going to be the first element right now. I'm cheating, but I just want to see prod dot name here. So the first element is where you're going to be storing things anyway. So I might as well do it here. Prod, I just want to make sure that the values got altered remotely. So 0 again. Dot price. Okay. And then comma. Prod, again 0. So the first element in the array. That's all I need to test for not right now. Quantity. Okay. Let me close this. Let's see if it worked. So let me compile and run. Okay, so we're going to add a product, add a new product, and let's call it Gizmo. Okay, let's put the price at 56.45, and let's put the quantity at 100. So we're entering data into the database. Let's see if they come out. And sure enough, we have Gizmo 56.45 and 100 printed in main. So that means the information did indeed get translated back to the local variable or the local element of within the array that was declared in main. And thanks to passing by reference, we were able to obtain that. So again, what do you mean by passing by reference? We actually passed the address of that array over to this function. We had full access to its elements right here. Right now, it will send back 0. So that is not what we want to do. So every time you add a product, you want to increment the count. Okay, so count equals count plus 1. So by the time you come back, you are now pointing, your product count should be 1. The first time, product count is 0, and it will be incremented by 1. So the next time I add another item, it will be added to the next item. So can we do that? So let's do this. Let's leave this one at 0, and I'm going to show you here quickly what's going to happen. And again, remember, I'm testing this stuff. I am going to do this again, so I'm going to copy this, copy here, and paste it right below it to see if we can get two products. And I'm going to make this one 1, 1, because remember, the next time I'm going to add a product count will be 1 because I'm inside of a loop, right? So let's see if indeed that's what I get. Now remember, I am just testing here. I will change all this to be more compliant with the application itself. This just gives me an idea if it's updating properly. And let's go ahead and compile and run. Okay, so we're going to add two products and see if they actually do indeed come out. So we're going to add one. Again, Gizmo. And that would be, let's say, 45.67 and quantity 100. Got an error. And the error is this. it's because it's trying to print the second element. There's nothing in it, right? But this is fine. The second element has garbage in it, which is fine. We're going to come back to it. So I'm not going to kill the program right now. It shows you that the ones with index 1 has garbage in it. This is fine. We're going to add another product, and we get to see that that garbage you saw will disappear. Let's call this one toy, and let's put a price of $12.78, and let's put 10 of them. Now watch what happens. Now that should have updated. It did, but it did not update this one. Let's see what the issue is. It wrote over the first one. So you can see here that it wrote over the first one. So let me just exit here. Okay. Let's see what happened. Did count update at all? Okay. I know exactly what happened. The pointer was never moved. You need to move the pointer. You need to move the pointer based on count before you start. If it's 0, great, you don't move anywhere. Fantastic. So maybe we need a for loop here to move this pointer before you do anything. So this is perfect. So this allows you to test and see what issues you're running into. So let's move the counter before the pointer based on this. Okay, let's do a for loop. So int I, okay, and I'm going to do a for loop here for I equals 0, I less than count, I plus plus, and you're going to increment the counter here. The pointer. PTR plus plus. Obviously, if it's 0, it will not increment it. You will be pointing to the first element. If it's not, we're going to be pointing to the next element. So I am glad we're doing this and seeing the errors so we can see how it's tracking it. So you need to move the pointer here. Right, so let's go ahead and do it again. Compile and run. Okay, and we shouldn't see that problem except the first time. Okay, so add a new product. Gizmo 23.45 100. So the first time, yes, I will see that. When I come back, that gobbledygook you're seeing at the bottom will be gone. So let's add another product, and let's put toy this time again, right? And let's make the toy equal $90, and let's put 45 of them. And there you have it. Now you have Gizmo at 23.45, 100, toy at this and that. And the reason we were able to successfully move to the next item properly is because we moved the pointer according to how many records we have in the array. Without that, we will not be able to populate prod 1. So this allowed us to move to prod 1, and if I keep going, it's going to go to prod 2, etc., etc. So I need another function. So the next part, we're going to create another function that will show me all the products, and we're going to do the printing outside of main, not here. So we're going to have, basically, if you pick option 2 from the menu, view all products, right? We're going to have another function just for this to view all products. Now, this is what I simulated here, just to make sure that we're allocating properly in memory where items need to go. And indeed it worked. But for the next part that I'm going to, part 3 that is, we're going to have a specialized function that will do the work for us and step through the whole array as large as the array might be at any given time.